Hey, welcome to my virtual session, The Happy Marriage of Redis and Protobuf. I'm going to give you a little bit of some background on me, who I am, why I'm here, and then we're going to take a look at the agenda for today's session. If this runs. All right, so me. I'm Scott Haines, and I'm a senior principal software engineer at a company called Twilio. I work on a product called Voice Insights, which is an analytics and insights platform for all of our voice connectivity and also like voice quality at Twilio. If you want to find out more about that, you can ask me online, talk to me during like our Q&A for RedisConf, or literally just find my email. It's online as well, shanes@twilio.com. All right, so the agenda for today. What are protocol buffers? Why use them? Why I love them? And why you should love them too. Second, we're going to take a look at Redis key patterns. So if you're familiar with Redis, and you're familiar with basically the idea of like keys and values, and now keys and data structures, we're going to take a look at how to actually create a really nice kind of key space model that you can use in all of your products, all of your APIs, whatever you have. Anywhere you're using Redis, you can actually follow this Redis keys pattern. We're also going to take a look at using Redis with Protobuf, kind of end to end. So how does that how does that union work? And how can you actually apply this to what you're building, wherever you're building that? So protocol buffers. These are actually created by Google, and they're used internally for TensorFlow and also other places as well. They've been around for a long time. I used to use them back in 2009 when I worked at Yahoo, where I first kind of got introduced to them. So protocol buffers themselves are literally just a language agnostic structured data format. So you think about Redis having data structures in the structured data store, you now have structured data going into the data structure store. And it's actually kind of an interesting, kind of happy union. And we'll see how that actually works right now. So starting off with Protobuf. I just basically was talking about the, kind of the language agnostic format. So we take a look at this message user. So we have basically a created time. So uint64 is basically just a long value. So we have a timestamp. We have a user ID, say a kind of simple nickname with a default, and then some kind of attribute. This data itself is literally here just to kind of build a mental picture of what Protobuf is. And we're not going to actually really use this. So it's more there just to kind of show what is the message format behind the scenes for Protobuf. And then we're going to actually take a look at a real kind of end-to-end example as we go forward in this presentation. So, said before that protocol buffers are language agnostic. That means that we basically have a format that can be compiled down to many different languages. So if you have some services written in Java, some services written in Go, some services written in something else that actually has a Protobuf client library, then you're pretty much good to go. The other nice thing too is that given that protocol buffers have to be compiled down, it actually fits really nicely into the mold of being able to version the data format or your structured data for your APIs, for your data pipelines, really anything that you are a steward of at your company or for your project. It really allows you to not have to really worry about breaking downstream dependencies and interoperating really well with many different services within your company or organization, wherever you do the things you do online. All right, so why else would we want to use these? The nice thing about Protobuf is that you can write a simple message, like we took a look at before with the message user. That message can then be automatically compiled down to your language of choice. So we're going to go with basically a Java Scala type use case right now. So if I was to compile the proto, I would now have a builder object. So a builder is really nice because it's a defined structured way of organizing and then generating an immutable type. In the case of this user builder we see on the right-hand side, we can set some or none of the values. And then once we build it, it's basically a sealed type. From there, we can basically cast it back to a builder if we want to, if we need to actually, go and add more stuff to it. But the nice thing is that the actual container itself becomes immutable. This is really nice for just reliability. And this pattern can be used to basically, add to your builder, even across threads in like a multi-thread environment, like a Java, anything running on JVM in general. The other nice thing too is that once you have these kind of, these little lightweight builder objects, and you have these, this predefined structured data, you have a really simple way of actually both serializing and deserializing that data. So in the example we have on the right, it's basically saying, okay, well, we created this user object, we built the user object. Oh, now we have the ability to basically cast this back to a byte array, so we can then send it over the wire. We could also stuff this into Redis, which we'll see in a further use case as well. Then, once you want to pick that data back up again, you can basically pick it up. It's just binary bytes. So you can say, okay, well, I have a simple primitive now where I'm still using the user object, and I'm just saying, well, now we can just parse back from the bytes, and now all we've done is basically rehydrate that data structure back again. So Protobuf really gives you this nice way of simply building from a simple message. Messages can also be complicated, and we're not going to talk about that today. But all of that serialization and deserialization, or SERDE, is all kind of baked into the platform framework itself, which is really nice so that you don't have to worry about doing that yourself. I also like to talk about how Protobuf is backwards and forwards compatible. I specify that it's the way that things should be, because it is the way that you would like things to be, and it's not always that case. I have an asterisk also next to the backwards and forwards compatible, because like many things, there's correct ways of doing things, and there's incorrect, backwards, incompatible ways, you're breaking changes. So with Protobuf, if you follow the best practices established by Google, then you'll have the ability to basically support backwards and forwards compatibility. But if you start actually changing individual types on your message, it's completely fine. Your new version is now just not backwards compatible. So the way that I've used this in the past is that we've kind of defined a binary snapshot for each version change in our Protobuf. And then all we're doing is basically unit testing that like we would in normal software, so that with every single kind of incremental release, all we're doing is ensuring that the first version of that message is continuously still backwards compatible. So if you think about like a huge kind of large distributed system, you don't necessarily have the ability to ensure that everybody who has access to, say, like this API, you don't have to force them all to basically do an update and then freeze the whole deploy, wait for everything to go out. It's a lot of hard work. So if you're just ensuring that things are backwards and forwards compatible, then services can basically opt in or opt out of new additions that you're adding to your to the data structure, or I guess structured data, which is actually a really good thing as well, because you're not having to force other people's timelines. The other nice thing too is that given that Protobuf is kind of a I guess structured data in general, and the ability to basically pass like these binary wire formats, it's sometimes hard for people to kind of understand exactly how that's working. But luckily there's also this, there's a library for basically converting your JSON to Protobuf. So given that your Protobuf definition looks a lot like JSON, it actually makes sense that you'd have the ability to read and write JSON from your Protobuf as well. So it allows kind of an interoperability layer from kind of, something that understands JSON but doesn't understand Protobuf, to maybe your server side, your server, whatever that's running in, say it's a Dropwizard project, that then reads your JSON, converts to Protobuf, can do all the validation, everything else at the server side layer, and then, act like a normal API. Was this a correct message received to handle this next request? Or am I sending you back like an error or something else? The other kind of interesting thing too is that if you really like Protobuf and you kind of go all in with it, then you can also compile down your RPC. So if you think about like a traditional kind of REST API where you have a route and you're sending data to the route like a JSON post body, now you can actually say, well, this route with this name takes this type of message and will return this type of message, and then everything can basically be fully binary for that whole entire kind of API contract. So I'd suggest if you really like Protobuf, or if you're kind of intrigued by this entire presentation, to really take a look at the gRPC offerings in Proto 3. Lastly, I'm just basically showing a use case of how to use the JSON to Protobuf layer. This is based off of it's the Protobuf message writer, message reader from Dropwizard. So this is basically just like an abstraction layer on top of how you send Protobuf back and forth with an API. Yeah, that's pretty much that. I don't have a. Let's move on. All right. So Redis Key Patterns. So kind of recapping, we've taken a look at Protobuf. Protobuf is a wire format that's language agnostic, that is basically enabling you to share very kind of strict compile time structured data. We're not talking about Redis. So basically identifying the two participants in our happy marriage. So first we talked about Protobuf, now we're talking about Redis. You're at RedisConf, so either you're interested in Redis or you're already using Redis. If you're already using Redis, then you're familiar with potentially the fact that there's a key. If you aren't, then there's a key. So every key has a type of data structure, be it a simple kind of key value pair to even being a stream value, kind of like a Kafka. And then a lot of things in between, like lists and sets and everything else. Take a look at the docs. They're awesome if you want to find out more about the different types of values that you can store in a key. But for right now, we're going to take a look at just the actual Redis key pattern. So Redis key pattern. This is something that I first saw when I was at Yahoo. I brought it into Twilio as well. And if you have been reading anything about the Redis 6 auth library, you'll see they have a very kind of similar format for exactly how they would suggest creating keys and kind of how to architect your key space. So in the case of like the Redis key pattern, I come from kind of a traditional non-clustered Redis background. Also know how to use Redis cluster, but kind of prior to the cluster, you had this notion of kind of multi-tenancy. So the Redis key pattern was a really good way of basically not spoiling the key space with potential collisions. So if you think about, a Java package, you have com, Twilio, whatever the name, voice insights. That namespace is basically there, so you don't have necessarily underlying collisions with classes. In the same way, you want to do the same thing for Redis keys, because you don't want to collide in your key space or potentially poison the underlying value stored in a key. So in this case, because you're applying a namespace, you're kind of creating a safety zone, guardrail for which all data from within that namespace will actually live. That's pretty much it for the namespace. In the examples we'll see in the future within this presentation, I'm just calling everything VI for voice insights. All right, so version, like you might think, it's a version of the data being stored within a key. I don't have to go too much into this, but if you think about being able to adapt to change or being able to test new things out, one nice thing is the simplicity in being able to version that underlying key. So if you have a namespace and we have no version, but you have, say, data category identifier afterwards, then a lot of times you'll basically be tacking on stuff to that key. And it's really hard to be able to figure out which version is which, or, in some cases, it's actually easy to kind of break, backwards compatibility also within your key space. So versioning a key is actually a really important concept when working with Redis, and also when working with Protobuf. So this notion of data categories, this is kind of for a lack of a really good description. So if you think about like a data category, it's denoting the collection or type of data being stored at a specific key. So if I think about like VI, V1 connections, which we'll take a look at in a little bit, that's basically encapsulating the fact that we have some kind of connection object being stored in a collection. They might also have an identifier as well. So I've kind of picked up on the plurality in naming convention. So a plural, like connections, would be a collection, while a connection itself would not be a collection, it'd be an individual key pointer. And we're going to take a look at that as we kind of go further and further and start to build up this mental model. So the identifier itself, I talk about this as being something that is optional because you have the ability to decide how you want to use these identifiers. In the example we're going to take a look at with this VI V1 connections, if you were to basically pop off the US1 from that key, you'd have a collection of collections or a collection of actual pointers to collections. We're going to take a look at just what that means in just a sec. But if you don't need an additional identifier, Or if you think about, the data category, in some cases being the identifier itself, that becomes sort of an optional field. So namespace and version and data category, or namespace version kind of unique identifier, it's kind of up to you. And I'm going to build out what I think actually works well and also what has worked well in production. But a lot of this stuff is a suggested use case, suggested pattern. Try not to dictate anything that you guys do in the future. So at this point, we've taken a look at what Protobuf is. We've taken a look at kind of a teaser of what the Redis key space pattern is. And now we're going to take a look more at how to start connecting the dots between Redis and Protobuf through an example use case. So behind you, or I guess behind, there's no behind because we're on a virtual session. So in front of all of us, we have a map. That map has a bunch of different locations. Those locations are points of presence. If you want to kind of build up the story. So the points of presence accept a connection, and the connection can then establish some kind of command, on behalf of the user who's connecting, or the an API or a server, non-user who's also connecting to a service. So connections can be between points. Connections can also be from an end user into a system. But at the end of the day, they're just connections. So what we do is we say, okay, well, we're going to establish the fact that I work at Twilio, a company that uses connections to do things. So I've created this example based off of very high level kind of paradigms within Twilio. But the messages and the content that I'm talking about right now are all just for this example. And they're not actually being used at Twilio for this use case. So just wanted to kind of put that down. It's like a legal disclaimer that it's not internal code that we're looking at. So accounts can connect to Twilio and then perform an action, like making a call or sending a text message. We're going to assume that a connection is basically available for every single event that's passed. So something is going to connect to issue some sort of event. So, say an account, say it's Uber, they want to connect and they want to, send an SMS to a user telling them that a driver is going to be there in 5 minutes. That can all be done with this kind of similar paradigm, where we basically connect and then you fan out to an underlying service that then receives a message and does something with it. So again, kind of reiterating the fact that if Protobuf is a message, and then an API can be a way of dispatching messages, and then these messages can then kind of also encapsulate the way that services are running, then some of this will also start to come together and make a little bit more sense. So we have connections. So we have a root key. And I said before that the identifier within our key space pattern is optional. So in the case of like VI v1 connections, this is encapsulating all connections globally. So we had those points of presence across the globe. Connections would say, we have all these different pops, points of presence. Now, within this actual set, we can now define a path right down to an individual location. So in this case, the example is basically saying that we have a point of presence at US1, US2, JP1. So basically East Coast, West Coast of the United States, and then Japan. This is Amazon nomenclature for those using like Azure or something else, just to let you know where these come from. So in this case, you have a root key. The root key itself is literally just storing a pointer to another collection. So VI v1 connections stores individual pointers to another collection. Let's take a look at what that actually means, and then also taking a look at the right. You actually have the underlying Redis CLI commands if you were to want to follow along with some of this as well. So as I said, if we want to basically descend into the collection underlying the collection. So all we do is say, okay, well, if we have the set member within VI v1 connections, all we do is basically pop out that one item, and then we append it to the root key, and now we have the key to the next collection. So if you think about this as a paradigm for, say, like an API route where you have VI or v1 VI connections or VI v1 connections, however you decide that you want to actually lay out your API, this would just be another path parameter. So your path parameter is now giving you the listing of all connections, they might be paginated, but all connections to that current availability zone at that given point in time. So if US1 has availability zones and the availability zone itself is US1 and people connect to it, then all you'd be doing is basically listing the UUID of something connected to that point of presence. So using the prior key, you're now just appending to the prior key to get the next pointer. So you think about this as a kind of like a hop along. So now we take a look at what does the information look like now within the set. So if we have a set and we say, okay, well, now we want something that has temporal information as well. The pattern in the past has been to use sorted sets. So a sorted set will still take a set member, and then it'll take a secondary sort key. In the case of temporal information, you can give it an epoch millisecond, and now you can actually sort the connections by time. So if connections have temporal information, we can use a sorted set. We also know that a connection is basically built off of underlying properties of Protobuf. So the Protobuf message for connection would say, okay, well, connection has created, it's got a UUID, and maybe it has a connection group, and the connection group is going to be zone US1. Well, how can we take that information that we want from that Protobuf object, and how can we create basically a pointer to that data? So if you think about kind of establishing, a way of using your underlying, the underlying Protobuf message to identify keys, then you don't have to pass as much information back and forth. So in the case of a server accepting a connection object, if it wants to go actually write the connection information, all it has to do is basically pull, say, the timestamp, the UUID, and then the zone information out to be able to go store that connection pointer to the actual underlying Protobuf. So we see here basically zadd, which is basically adding to a sorted set, the vi v1 connections, which is the root path to the connection to the sort to the set of connection objects. Then we have a zone, so US1. So same exact thing we're looking at above, vi v1 connections US1. We have a created date, which can either be the time that an API server accepted this request, or someone else could also pass the created from a put API or post API. Then from there we have a UUID. So the UUID would either be associated with a session for if a user is connected, or if, like, say, an account is connected to the server, or we could also be randomly generated depending on how you want to go. So that's always up to you as kind of the builder. This is just a way to take a look at that and move forward with it. So how does this actually start to work? So if the set member is a unique identifier to each of the underlying connections, then we also are storing, if we want to, potentially the binary data in another key as well. So I talked before about plural. So if you have plurality in the underlying keys, then vi v1 connections US1 is a pointer. It's a collection that points to individual objects. So using that information from the zone, the created time, and the UUID, we can either rebuild the Protobuf object just by taking that data back out again, or you can also encode the Protobuf directly into the sorted set. So if instead of adding the UUID as the value inside of the sorted set, you can also add the byte array of the underlying connection into the sorted set. But that comes at the expense of not being able to really easily make additional changes to the underlying Protobuf type, because if you have binary data inside of the sorted set, and then you're adding new types to the binary data, you might get duplicates. So that can be problematic, given that you don't necessarily have a pointer to a specific, serialized version of a single connection, in theory. If you were to take, instead, the UUID and use that as a pointer to the actual underlying Protobuf, then it's actually a lot easier to go change the way that things are working, even within the same versioned release, as long as you're not breaking backwards compatibility. So we're going to take a look at that. So if you have the actual binary data stored as a singular connection, so vi v1 connection with that UUID, this is in kind of a simple world where we don't have to worry about clustering or anything else. So this is the most kind of basic. So we have a connection object that's been built. All we're doing is basically identifying the UUID, the created data, and then we're just converting that connection object back to a byte array. Then we're creating that key. And then we're setting the key in the bytes with any kind of retention second expiry. if in the world where we actually wanted to also handle, clustering by zone, you might have a regional Redis that's storing all the connections in a specific region. Then you could also follow this pattern, and all you'd be basically doing is lifting up that zone information. So all we're doing now is saying, well, we had VI V1 connection. We're introducing zone, and then we're just adding the UUID as well. So still following that same kind of pattern where we have the namespace, we have the version, we have the data category as a connection. And then from there, our identifier is now basically just an aggregate identifier, if you want to think of it like that. So US1 UUID is your identifier, or you can also say, well, the connection group now has an identifier, and that identifier also has an identifier, but that becomes kind of squirrely to say that out loud. But again, as long as you're following kind of a rule, and that rule can be dictated in your code, and it's also shared with the downstream dependencies, then it doesn't really matter what you do, as long as it works really well for you. We're going to take a look at how some of these patterns can be fulfilled through shared code as well in just a little bit. So I said just a little bit, and here we are. No breaks except for a little bit of water. So I'm going to have that right now. So basically recapping. So we talked about Protobuf. We talked about the Redis keys pattern. I've talked about through example how you would take a connection and then separate, say, a list API for individual connections in a specific region, like US1, and then how you would actually create a series of pointers to point all the way back down to the binary data that has been stored inside of Redis, which was encapsulating a connection. Now we're going to take a look at how do we start to create this framework around all these thoughts that we've had, so that we can get to the point where it's really easy for anybody to pick up and really understand through example, intent. So if we have a Redis key, what we have on the right-hand side is an example message again. So the message is Protobuf. So it takes a namespace, and the namespace is another message, or could also be an enum. So in this case, we have an enum. Version itself could also be an enum value. Data type could be an enum value. Data category could be an enum that points to another category. A lot of this stuff is sort of flexible, so that the end user, you guys out there, can do something interesting that you want to do with this. Also, as like a kind of simple primitive as well, your Redis key itself could literally just take a namespace as a string. You could take a version as a string, and you could take kind of each individual component, like including like the identifier, even just as a string value. As you get more kind of seasoned with Protobuf, you'll start actually using messages embedded a lot more. So at that point, you can really do what you want. You can be a lot more flexible and also a lot more strict. So start simple and kind of build, and that's what ends up kind of working. So Redis key, going back to this. So we can add structure, we can enforce format and convention. We can use this Redis key message to be able to automatically generate the key that can be inserted into Redis. And this also allows us to basically have binary keys as well. So given that the key space in Redis is also hyper optimized, your Redis key itself can also be storage of more information. So the Redis key can be a binary key that's pointing to binary data. And so both of those can actually be Protobuf. So then when you're actually going to fetch that information back out from the Redis key, great things can happen. So it's really up to you to figure out something that you think will work well. But in the case of starting off simple, you can start off even just, by having every key be, written out as a string. Really it's up to you, experiment. Lastly, also, your Redis key payload can also, give hints to the system for how to basically follow certain rules. So whether that's the expiry or, it's, adhering to specific GDPR rules, by cleaning data before it's being written somewhere, all that can basically be dropped into that Redis key message. And then all of that can be handled on the server side, so that you just basically write it, define it, and send it on the wire. So Redis keys Scala trait. So a trait is an interface in the Scala world. And in this case, the Redis keys trait would have a namespace, it would have a version, it would have now a helper method that allows you to basically say, okay, well, for a namespace like VI, for a version like V1, I want to now create a key for a specific data category. So say it's a connection. When you create that key for, this is basically just a kind of paradigm that you can follow to kind of create these wrapper layers on top of both the Redis keys message hierarchy and also underlying protobuf data, which is bound to the value at each individual key or collection. So the nice thing here is that you can support multiple namespaces, multiple versions, literally just by extending this. So for example, if you have connections and connections maybe have information about some kind of additional service, then all of that can basically be written into its own shareable module. And it's really up to you as the builder again to do what you want with that. So I'll show an example of what you can do with that in just a sec. So we have now the Redis key, which is our underlying protobuf. We have Redis keys, which is an abstraction on top of the Redis key, which allows you to easily create a Redis key for a specific version in a namespace. And then we have the ability to kind of abstract further on top of there to create a utility method that allows us to basically define a key for a namespace and a version. Then also, it would make sense to have some kind of registry for our data categories or our types. So in this case, you want to store, say, a data type to a protobuf mapping. You can do something like this with the type registry. You can also basically use some of the stuff that's built into the Proto3 libraries. So they have a type registry as well for some interesting things like their extensions libraries. Also, they have the ability to send kind of a generic any type. So in that case, you have to basically bind specific names into your type registry. So for this use case, though, if you're to have a Redis keys pattern that ends up having a Redis key that points to a specific type of data, then if you were to use the type registry along with the other traits as well that we've seen up to this point, it will allow you to actually say, well, now we have a really kind of structured way of basically creating Redis keys, of figuring out what data should go, for the read-write path, and then all of that can be abstracted out so that engineers or other people who are using your client libraries to mix basically the Redis and the protobuf together. All of that work can be done, and as we'll see in just a little bit, in a fairly trivial way, I guess simplistic. So if we were to talk about continuing to layer on these abstractions, another thing that you'd want to potentially look at is something, say, like a Redis data store, Redis data source. So this is basically, this would take keys, take a type registry, and then it has specific methods like a put and a fetch. So it could be whatever you want. It could be a get, it could be a list. You can kind of extend this however you really want to. But the nice thing is that if you've kind of defined all of these like base level abstractions, then you can actually open the doors to some kind of really interesting use cases. Also, the other thing that's kind of worth pointing out is that if you've abstracted away like the Redis connection, you can also easily switch Redis versions. So if you don't have to think about, okay, well, this is a client working for Redis 6 or this is a client working for Redis 5. This is supporting TLS by default. This one is actually using the auth module. A lot of that stuff can be defined outside of the client library that's being used by other, say, teams within your organization or at your company. So then at that point, testing is easier. Security is basically coming by default. And then, it's up to, again, the builder to really do what you want on top of this. So if we take a look at, say, kind of a fully encapsulated, implementation of this Redis source, then here it is on the right-hand side. So if we were to say, okay, well, we have this keys. Keys is basically taking this Redis keys pattern, and it's basically injecting in a namespace, and it's injecting in the version, the actual, the enum versions of the underlying types. So namespace, voice insights, version 1. Source now is how we actually talk to Redis and how we actually use like this underlying key binding. So if you were to think about this and say, okay, well, Redis source has a keys in a registry. All I want to do now is say, okay, I want to get this value. Then through the lineage of actual abstraction, you can say, okay, well, the key for this value traverses the lineage up to this specific pattern. And now we're going to go to this, the namespace, the version, the data category to go get the type. So a lot of the abstraction, like whether or not to add, like a zone identification for a connection, that information could be done behind the scenes as well. And you're basically just mixing in what you want in these APIs. So in this example, you have something that's kind of completely abstracted away the complexity of using both Redis and Protobuf together. The other nice kind of side, the nice kind of benefit is also that, you can simplify your unit tests this way. You can kind of easily create, these kind of common modules and libraries. So reduce time to production with projects that interact with Redis in the same exact way, or in a way that you believe is the best practice for your organization. All right. So also the nice thing too, if you don't have to worry about all the levels of connection, how people want to write certain things, and you're kind of abiding instead by kind of a common interface, you have the ability to basically enhance the readability and maintainability of your code. So as I was saying before, you can abstract as much or as little as you want to solve a common problem. You can also abstract way too far. So it's really up to you again. For the example on the right-hand side I have right here, this is kind of an end-to-end idea. And again, this could be encapsulated, a lot more if we wanted to. But to prove the point that by having levels of abstraction, you can actually get things accomplished easily. This is what that example is. So if we read it across the top, we have basically the connection. So connection new builder, build. We're adding data to that. We've seen different versions of connection before. So just either go back to that individual slide where we took a look at what a connection could look like. And just think about this being a connection object. So then we have basically the source object we talked about before. So the Redis source. And so basically Redis source has Redis keys baked into it. So we can say, okay, source.redis keys, I want to get a key for this connection category. I'm going to pass along my UUID. At that point, you get your key. So then all we have to do is say, okay, well, now the source, I want to put this connection with this key that I just built and this object, and you're going to basically go put this into Redis. Say I want to go now and fetch that data back out again. I don't have to even think about how it actually works. I can just say, hey, source, I want to go fetch this connection. Here's my key. And for a lot of the stuff, as I was showing in kind of prior examples, to recreate the Redis key, we had different versions. So your key for could basically explicitly take, Protobuf. It could take the data category, but you can also just build it however you want to as well. So instead of having the key for, you could potentially have a connection key builder. Connection key builder could then take the information to rebuild your key. Again, it's up to you. So kind of finishing out this whole entire kind of paradigm, we move on to basically, what happens if we were to extend even further? So given that you have connections, and if you were to basically fetch every single connection, say one by one, in the case of, having n number of connected, say users at a given point in time, or, API, consumers or producers at a given point in time. Then sometimes you want to think about pagination. So say you have maybe it's a UI that's being used for DevOps or something else like that. Then with this, you could basically just be able to go through and say, okay, well, I want to go now list a sequence of connections. I want to basically add a sort to it which is descending. Given before we talked about like the temporal accessing through the sorted set by timestamp. So if I think about kind of extending this paradigm for, further and further and further, my key at this point to get my sequence of connections would be the key for connections plural for a specific zone, or we could have it for all zones. But in this case, if you think about VI, V1, connections, US1, that would be my key. So that key itself would then take a descending sort order, which would give my my zrev range by, in this case, value. So I have my offsets and I have my limits. This will allow me to basically skip ahead in reverse order along that same sorted set. And then, lastly, I can also say, well, maybe I want this to time out at a certain point. And then I want to just, add this directly back into my Scala code. So all we're looking at here is basically a list of sequence connections for a key in descending order. Basically starting at the head, moving back 1,000 records. And then I just want to take, 10 items at that point. This can be done in many different ways. This is just, an example of how you can kind of extend the client library. And then, from there, it's up to you how you want to move forward with this. Do you want to extend this to Redis streams to have a kind of a streaming connection that abstracts away, the binary data stored inside of a stream, that's another good use case. So you want to inject a different library. I use Redis. Maybe I don't want to use Redis. I want to use something else. The abstraction layer would be the ability to basically, it would allow you to go plug an additional client library without really having to change anything else, as long as everything still worked as expected. So it's a nice way of kind of plugging different client libraries, or also, supporting, backwards and forwards compatibility with an API across versions. It can all be kind of, bundled into this pretty present that makes more, more people in your organization more productive. So that's it. Hopefully this was informative, useful in general, good use of your time. And maybe, if nothing else, maybe think a little bit more about the way that you're architecting, data inside of Redis, and what those access patterns are. So thanks a lot. All right, cheers.